Now let's start with question number 11. In this video, we'll be covering from question number 11 to question number 20. So in question number 11, we have been asked typically amides will hydrolyze under dash conditions than esters. So we have to figure out whether the conditions have to be harsher or milder. Now, if you see, NH2 is a bad leaving group as compared to OR. Okay, I have written OH minus by mistake. So nitrogen is a poor leaving group. Hence, leaving when the hydrolysis is happening, leaving this NH2 and getting OH over here or replacing NH2 with OH would be a difficult task to do because of the poor leaving group ability of NH2, and hence the conditions which are required are more vigorous as compared to esters when the hydrolysis has to happen in the basic medium. All right, so this is the answer for question number 11. Now come to question number 12. So in question number 12, which of the following esters undergo hydrolysis in the basic medium most easily? So hydrolysis will happen most easily only and only if we have good leaving groups present and at the same time delta positive on the carbon is strong. So the leaving groups are pretty much same everywhere. If you see, there is a OR group over here. Here also it is OR. Here also it is OR, and here also it is OR, and here also it is OR. So that means leaving group is not something which is affecting this reaction. It is the delta plus on C double bond O which is going to affect, and we'll see where the delta plus is strongest. So here in this compound, NO2, that is electron withdrawing group, is present, which will increase the delta positive charge on the carbon of carbonyl, and hence the reaction will be fastest in the fifth one. So answer should be E. Now let's talk about question number 13. In question number 13, what is the product obtained from the following reaction? So this is the reaction given. One is acid, another is alcohol. In the acidic medium, naturally has to be a esterification reaction. We'll just quickly see it with the mechanism. So H plus will affect this oxygen, will form OH plus. At the same time, this alcohol will attack on this carbon, which is carrying a delta positive charge. So this is how the system will look like. When this oxygen will attack on this carbonyl carbon, it will carry a positive charge, and because of that, it will try to cleave the bond with hydrogen. Okay, so when it will cleave the bond with hydrogen from here, and when it will cleave the bond with the hydrogen from here, it will be forming. So H plus will be coming out. That H plus can go and attack on one of the oxygens. Okay, any of the oxygens over here on this alcohol or this alcohol, and it will form something like this. If you see, OH2 plus is being formed over here. Now after this OH2 plus is formed, protonated alcohol is formed, the water will lose its H2O from here, and at the same time the lone pair of oxygen will try to form the bond with the carbon again. This is nothing else but the esterification ka mechanism. So this electron density this bond will break. At the same time, this oxygen will attack. So loss of H2O will be out and H plus will be out, and we will be getting the respective esters. So acid was acting as a catalyst, that is out. Even water from the molecule will be out. So the option number is, this is your option number 4, D. Now come to question number 14. What is the major product of the given reaction? 2 benzoic acid and 1 glycol is given, ethylene glycol. So we have to understand esterification, how is happening here over here. So basically it is nothing else but the esterification reaction. Same way how we have seen earlier, H plus will be attacking this carbonyl group first, forming a protonated OH plus. At the same time, alcohol will be attacking over here. This bond will be cleaving, and this kind of system will be generated. Now this oxygen hydrogen will cleave, and hydride shift will happen on any of the OH. So let's suppose it has attacked on this OH. It will form OH2 plus. When it will be forming OH2 plus, it will be cleaving its bond here to get rid of the positive charge from oxygen. At the same time, this oxygen will be giving its lone pair, kicking out the hydrogen at the same time. So minus H2O and minus H plus will happen. So this is how the ester will be formed. Now we have another carboxylic acid also, which can go in the same pattern reaction again. H plus attacking on this oxygen, forming this type of molecule, and then the alcohol from the other group will attack on this carbonyl carbon, and ultimately going through the same process. This oxygen will withdraw the electron density back. this oxygen, this OH oxygen will gain a positive charge. This bond will ultimately cleave, and this hydrogen will go on any of the OH, forming OH2 plus. Now this OH2 plus will try to cleave the bond. At the same time, the another oxygen will try to give the electron density to the molecule or to the carbon. So loss of water molecule and loss of H plus both will happen, and we will form two ester linkages on the molecule. This is our option number 3. I mean C. Now come to question number 15. In question number 15, again we have an aldehyde and alcohol. Aldehyde and carboxylic acid on benzene, and we have NaBH4 which is doing the reduction, and then followed by H plus and heat. And we have been asked what is the compound B going to form. So this is the compound given. We have an aldehyde group and we have a carboxylic acid group. NaBH4 will affect only aldehyde group and will form its respective alcohol. After this, it is very simple. Again, acidic medium, heat is given, esterification will happen. OH from here and H from here will be out, and the cyclic ester will be formed. Again, question number 16, benzene per 2 carboxylic groups are present, and we have been asked to react with the CH3OH, that is methanol, with having the oxygen 18 to understand how exactly we are doing the esterification. And H plus is given. So always remember, this is a trick to remember, that OH goes from carboxylic acid, and from alcohol it is always the hydrogen which goes, not the oxygen. Okay, though we can also do it through the mechanism, but we have done the mechanism many times in the video, so I'm not doing it through the mechanism but through the trick. So esterification will take place, OH from here, H from there, so O18 will remain in the ester, that too with the R group. So O18CH3 will be formed up and down both sides, and this is our compound B. So answer is B. Now come to question number 17. Which of the following carboxylic acid derivative is most easily hydrolyzed? Which means you should have the stronger delta positive charge and easier leaving group. So among all the options, this is the one which has strongest delta positive due to -I of Cl. Also, Cl is the best leaving group among all the given compounds. Hence, the answer would be B. We have seen these questions many times now. Now come to question number 18. Again, completely opposite question out. Which of the following carboxylic acid derivative is most difficult to hydrolyze? Again, poorest leaving group wherever is present, there, and the delta positive wherever it will be least, there the reaction will be difficult to do. So NHCH3 is the poorest leaving group. Hence here this will be the answer. Now come to question number 19. Which of the following compounds will not undergo hydrolysis by H3O plus? All these compounds, amide, cyanide, and imine, all of three in the presence of H3O plus tends to form the carboxylic acid, but that's not what happens with CH3NH2. CH3NH2 cannot hydrolyze because NH2 is a poor leaving group. Okay, so this reaction will not take place over here. No reaction will take place. Instead, here in all these cases, the reaction will happen. Nucleophilic attack, electrophilic attack on nitrogen, and then nucleophilic attack is not gonna happen in case of amine, again because of the NH2's poor leaving ability, whereas all these three compounds can do the nucleophilic addition first, and then nucleophilic addition and then removal of the leaving group through SN2TH type of reaction, and hence the reaction will happen that way. Come to question number 20. Reaction is given, C2H5OH reacting with PI3 forming A, then KCN forming B, and then hydrolysis forming C. Simple question, C2H5OH with PI3, SN2 mechanism, it will form iodide, then KCN, again SN2 mechanism, will form cyanide, and after hydrolysis will form the carboxylic acid and will release the NH3 gas. So this is your option B. So here we are done with the 10 questions from 11 to 20. In the next video, we'll be discussing carboxylic acid and their derivative questions from MSC.